In this next example, we are taking the definite integral. We are evaluating this function. F of x is going to be equal to the integral from 0 to x of cosine t dt. Now this is different because we're not used to seeing a variable up here, okay? But we're going to evaluate it as if it were a number. So the integral of cosine of t is sine of t. We're evaluating from 0 to x. I simply substitute in my x minus, I substitute in my 0. And what happens is I know sine of 0 is 0, so that goes away and I'm left with sine of x. So what I can do now is I can set x equal to these 5 different numbers, and instead of substituting them into here and going through this integral again, I can simply substitute them into my answer. And so, for example, if I put 0 into here, sine of 0 is 0, that means that the area is 0. And that makes sense. If I'm going to integrate from 0 to 0, I have no area to be able to find. So that answer is 0. In this example, we're looking at substituting in pi over 6, which is 30 degrees, into our sine function. So I drew a triangle here. This is 30 degrees and 60 degrees. Remember, our numbers are 1, square root of 3, and 2, 2 being the larger of the 3 numbers. So 1 goes across the smallest number, 2 goes across the largest number, and the middle number would go across the 60. Sine of pi over 6 is going to be opposite over hypotenuse, so we end up getting 1/2. That means from 0 to 1/2, this area underneath our curve here is going to be 1/2. The next one is pi over 4, which, if you recall, is a 45, 45, 90 degree triangle. So we have 1, 1, and root 2. And if we're looking at sine, we're looking at 1 over the square root of 2. I can rationalize my denominator by multiplying by root 2 over root 2. And I get root 2 over 2, which is the area from 0 to pi over 4. This is called an accumulating function. So we're able to continue to change that x value and be able to accumulate more and more area. On this next one, we're looking at pi over 3, which is 60 degrees. So here's a 30, 60, 90. And sine is going to be square root of 3 over 2. The last example is pi over 2. We know that that's at 90 degrees, which is the point 0, 1. This would be the cosine. This would be the sine, so the sine is equal to 1. We have one more theorem for this section that I'm going to teach you. It's called the second fundamental theorem of calculus. If f is continuous on an open interval I, containing a, then for every x in the interval, if you take the derivative of the integral from going from a to x of f of t dt, all we simply have to do is substitute in our x into this function to get our answer. Let's take a look at this example. Example 7, we need to evaluate the derivative of the integral going from 0 to x of this function right here. Because square root of t squared plus 1 is continuous on the entire line, we can use the second fundamental theorem of calculus. So the derivative of the integral going from 0 to x is just simply going to be this function substituting an x in for the t. So we will get square root of x squared plus 1. So this is the second fundamental theorem of calculus. Another example. Example 8, find the derivative. We're looking at integrating from pi over 2 to x to the third power of cosine t dt. So here we are. We're taking the derivative of an integral, so we can use that second fundamental theorem of calculus. We know the cosine function is continuous. Now this one is different than the previous example because instead of going to x, we're going to x to the third power. So what I'm going to do is I'm going to do a little u substitution. I'm going to say let's let u be equal to x to the third power. That way I can use this second fundamental theorem of calculus. So I can take the derivative of the integral, and instead of going to x to the third power, I'm going to substitute a u into here. The only difference is it's kind of that chain rule philosophy. I'm going to have to multiply by du dx, which is the derivative of u. So if I go through here and use the second fundamental theorem of calculus, I am simply substituting in u for my t here. Okay, so I get cosine of u. But then because of the chain rule, I'm going to have to multiply by du over dx, which is the derivative of u. Derivative of u is just simply bring the 3 down and then x squared. So it would be times 3x squared. The last step will be to substitute what u is. Remember, u was x to the third power, so our answer would be cosine x cubed times 3x squared. Parkland's curriculum does not have these next 3 slides, so we are actually done. If you see any homework problems that have anything to do with a net change or movement of particles, let me get to that last page. Okay, solving particles in motion. These are all topics that are on the AP exam, but they are not in Parkland's curriculum, so we do not need to do these examples. Okay, enjoy your day. See ya.